Welcome to today's presentation about hacking. Now, it's often said that if you want to find vulnerabilities in your code, then you should just think like a hacker. But that's actually a bit like saying that you have to think like a cook if you want to make good meals. So today we're talking a bit more about what hacking actually is and how hackers think. Now, my name is Jarmo Lahtiranta. I've been working in security for about 7 years. Started out as an ethical hacker, and the last 3 years I've been working on product security, so actually helping developers build more secure products instead of breaking them. And so what is hacking? So hacking in a professional sense is close to something like penetration testing or vulnerability testing. But the idea is just, well, basically finding vulnerabilities and writing exploits or using known exploits to break things. And basically there's this progression. So you have bugs, but not all bugs are a problem. Some are just bugs. But if there's a security implication in a bug, if it can be used for nefarious means, then it's a vulnerability. Then when someone actually writes code which makes use of this vulnerability, then that's called an exploit. And when someone uses that exploit, then that's called a compromise. And so just having vulnerabilities isn't like the end of the world. But when someone actually compromises your system, then that's not cool. So why do we have vulnerabilities? Well, it turns out just getting things to work can be really hard. And when you kind of drill down to it, it isn't even about code. It's more about people. So writing secure, actually creating secure products requires an secure development lifecycle, but that's a topic for another talk. But basically, all the developers always have a lot of time pressure. They have different priorities, and these security features are very easy to kind of leave in the backlog and do later when you have time, like you always have time later. Generally, people usually would like to write secure software, but there's just so much other stuff that they would also like to do. So here we are. But about hacking, it isn't actually about breaking the rules. It's more about knowing the rules better than your opponent. So, for example, knowing the system better than the people who created it. So if I want to hack some device, the first thing that I will do is go read a manual, go check out the documentation, learn how to use the system. And even in that case, you might already find that, okay, there are these default credentials, and you can actually turn this encryption off and that sort of stuff. And then there's knowing the typical mistakes that the developers make, like just basic human errors. Personally, I've been developing web applications for about 10 years before I started in security. So I wrote a lot of PHP code, and I probably did all the mistakes that a developer can make, probably even a bit more. So I know how to mess up. So that actually also helped me as a hacker, because I know the typical points of trouble. So we have vulnerability classes like cross-site scripting and SQL injections, and they've been around since forever. But the fact of the matter is that we get new developers every day, and every day someone is writing their first database query, and they are making their first SQL injection vulnerability, and that's just the kind of world where we have to live in. So hacking is also about knowing the typical edge cases and rarely known features. So stuff like legacy modes and that sort of stuff that's just kept there, and the developers actually would like to get rid of them, and they actively try to forget that they exist So that sort of places are great for finding vulnerabilities. And finally, yeah, just when you have all this knowledge, then you understand how you can kind of bend the system to your will and make the system do what you want instead of what the developers intended. And yeah, there are a lot of tools and they are constantly evolving, but they are just tools. They are just there to make your work easier, but the key is the knowledge and understanding of kind of how things work. So let's take a look at some vulnerability examples. So here's the first one. Let's say that I want to make an SSH connection to this jump host at my company. And I also want to create this this tunnel for forwarding traffic from my local port to the internal network. Now, thinking about this from a SSH server developer standpoint, it would be kind of logical that when you set the connection up, you also set the port forwarding up at the same time. But what happens when you log in using SSH? Well, the first thing that you do is that you write your username and password. So if the port forwarding would be set up at the same time as the main connection, then you wouldn't actually need to know any credentials to get this port forwarding up. You could just stop at create the SSH connection and just leave it hanging at the login prompt, and you would immediately get access to the internal network. And that wouldn't be optimal, let's say that. So these kinds of vulnerabilities are what's called a logical vulnerability. You couldn't find these like using a security scanner or source code analysis or anything like that. Everything's working the way it's intended to work. It's just that the design is wrong. And moving on, I guess many of you have heard about SQL injections. And the gist of it is that when a database query hits the database, it usually looks something like this. So this could be a login prompt, the database query that's caused by a login prompt at some website. So select everything from users table where the username is what we entered and the password is blah blah blah. We don't really care about that. So if my username is this, then it just looks like this, and this is pretty benign and normal. But what happens if our username looks like this? So now we have my name and this strange payload. So now the query actually looks like this. Select everything from users where username is Jarmo, or A equals A, and stop executing everything. So what's happening here is that the input isn't handled or validated properly, which enables us as a hacker to inject our own content to the SQL query. And that basically means that we can run any query on the database that we want. But in order to create this payload the way it is, you again have to understand what's happening beneath the surface. You have to understand the context where this username variable is and what kind of things you have to inject there so that you get to run your own queries. So yeah, let's take a brief analysis of this. The bug was improper way of creating this query. This is called an SQL injection. And yeah, the exploit impact can be a bit difficult to assess. So obviously we can bypass the login. We could log into the system, but we could also read arbitrary data from the database because we can do these queries. But actually that's not all. In one assignment that I did previously, we were testing this test environment. They said that, oh, it's just a test environment, you can do whatever, there's no actual production data there. But it turned out that yes, the database was test database, but the SQL injection allowed us to access other databases on the same database management server. And we could actually access some production data from another system, although we were testing this test environment of this system. Let's take another example. So in my previous job, I was sitting at my desk and I heard someone say that we write the values to a SQLite database from the command line. And I was pretty horrified about that. And let's see why. So that basically means that they are using structure something like this. So if they were writing Python, they would import operating system and use basically this system function, which enables them to run commands on the operating system. And then they would use a command like this. So SQLite 3 to this database and insert here's the SQL query. And of course you can see that there's the same SQL injection vulnerability, no problem there. But what if our value actually looks like this? So here's the end result. Now you will be running this code to the SQLite 3, which doesn't make sense. And the SQLite 3 will be, what's that? But we don't care, because after that we run this part of the code, which actually deletes all the files, which deletes all the logs from the server. And then again, here's some stuff that we really don't care because we already deleted the logs. So here's the payload. Another analysis. It kind of looked similar, but this time the bug was this dangerous use of a system function. And the vulnerability was actually remote code execution. So previously we could run our queries on the database, but now we could actually run code on the server. So yeah, a lot of hacking is just like you put what, where, and as a developer thinking that, well, this is a bit difficult and time consuming to do properly, so I'll just cut some corners and no one will ever figure it out. And that's like a recipe for disaster or a great opportunity for a hacker. So yeah, we usually figure these things out. And yes, there is this thing called security by obscurity, and it does help, but you should only use it as a secondary control. So definitely as a defender, do all the things that you can do to make hacking more difficult, but don't rely on just hiding things. Also, if you create these shortcuts, you actually end up in a situation where if you actually have the time, it can be really difficult to fix later because you did it kind of not so optimal way at the beginning. Now, let's look at the tools of the trade. There are basically two ways to hack systems. So either you are doing black box hacking where you know nothing about the system beforehand. Other option is to do white box hacking where you actually have credentials, documentation and access to the internals, or you know the development team and that sort of stuff. And white box hacking is generally a lot more effective and you get a lot more results because, well, you have a lot more information. That just helps. And there are two different kinds of vulnerabilities. So known vulnerabilities are such that someone has already found them. So all these huge disasters like Heartbleed and all that sort of stuff, that's just the one known vulnerability. Someone has found it, and then you can make sure that your system doesn't have it. And then we have unknown vulnerabilities, which are brand new and you can find them. So let's say that you're developing a system and you have a new cross-site scripting vulnerability there. Then that's an unknown vulnerability because it's brand new. Even though we do have like XSS vulnerabilities, they've been around since ever. So yeah, when hacking is about understanding the systems and also making educated guesses to find the weak spots, the tools are making this guesswork a lot more effective. there are different categories of tools, and most tools fit several. So scanners usually have some fuzzing capability, and some attack proxies actually also include scanners and fuzzing and so on. So yeah, this is a kind of a rough outline. But also, there are different environments and different tools work in different environments. So you would probably use a different scanner or a fuzzer if you were working in a cloud or if you were working with an embedded system, for example. So let's first take a look at the vulnerability scanners. The first category here is scanners, and I'm going to show you a demo of a vulnerability scanner called Greenbone. It was previously known as OpenVAS. So here's how it looks. And using it is really simple. Basically, here's this nice little wizard, which asks you which IP would you like to scan. You put your IP, target IP address there, and click Start Scan, and it just starts scanning. It takes some while, so I already have the results here. So you can see that it took half an hour to finish. And the way this works is that it first does a port scan, so it found a lot of open ports here. And it has a list of huge list of known vulnerabilities. So it could detect all these different vulnerabilities just by probing the server through those open ports. So we have things like rlogin, rxx service, Apache Tomcat vulnerabilities, VNC, and so on. You can see that these vulnerabilities are kind of network related because, well, it just had the open ports to go with. When you click a vulnerability, you can also get additional information. So what is it? How was it detected? What's the impact of this? And most importantly, how you can fix it. So these are really easy to use and nice. I also ran this scan a second time, but this time I also gave the scanner username and password, so it could actually log in to the server. And this time we got a lot more results. So if you look here, we had 65 vulnerabilities. When we look at the credentialed scan, we now have more than 200 vulnerabilities. And let's look at the results. So now the vulnerabilities also include internal components on the computer. So ktorrent, libxml2, vim, like these are not visible to the network, but either way, the scanner could find them because it could log in to the server. Now we're going to take a look at a different tool. So this is called a SQL map, and this is meant for just finding SQL injection vulnerabilities. And let's say that I suspect that this login page has this vulnerability. So I try to log in, I see what kind of data it sends, and then I will feed that information to my trusty SQL map tool. And this is also a command line tool, like so many other hacking tools. So here's the URL, here's the data, and I also told it that this probably is using MySQL database. So let's see what happens. It's making a connection. Yes, I definitely want to use this session cookie. And basically I'll just accept all these default values that it's asking, and you can see that it's testing different things here, different types of injection methods, some depending on different versions of the database engine. And yeah, exciting to see what happens. All right, the post parameter username is vulnerable. Do I want to keep testing the others? No, I think we're fine at this point. So there you have it. It found several different ways of exploiting this current vulnerability, and now we could just report this to the devs, saying that, okay, you should probably take a look at this login page. Now, when we compare this to the Greenbound results, in that case, it just found those vulnerabilities that had been found before, but in this case, we probed this site to find a new SQL injection vulnerability. The Greenbound could give us accurate instructions on how to mitigate and how to fix those things, but in this case, we would just know that, okay, this form has an injection vulnerability, and we would have to find out what to do and how to mitigate it ourselves. So scanners are a great tool for catching this low-hanging fruit, and also you can use them for finding new vulnerabilities. But the key in this, again, is understanding how the scanners work so that you can interpret the results. So the results depend a lot on how you're running the scanner, what the scanner can reach. So even if you don't get any results, that doesn't mean that, hey, the product is secure. It just means that the vulnerabilities that are there weren't found by the scanner. The next category is fuzzers and fuzzing. Now, this is a bit of a gray area because, for example, Burp Suite has some fuzzing and also scanning capabilities, and I guess you could also call a SQL map a fuzzer, but basically the idea is that you're mutating data in some intelligent way to find new unexpected behavior. So basically throwing some intelligent garbage at your systems. And yeah, this can be an art form of its own. So for example, Google is running 30,000 VMs on their cluster fuzz instance. But the kind of key point to take home here is that when you're doing fuzzing, it's really important that your fuzzing is focused on the correct part of the stack. So again, if we're thinking about this login page HTTP request, then yeah, you need to be able to hit that login username or password field. So if you're using some generic fuzzer and let's say that you're actually fuzzing the IP address field of the packet, then it won't even arrive in the correct destination, or maybe you will break the HTTPS connection or something like that. So you have to select the correct tool and use it in the correct way. And these can be a bit difficult, like some protocols, for example, they can be stateful. So you actually have to kind of make sure that your fuzzer's internal state is the same as your targets. So I guess because of this, many of the commercial scanners I hear that they are really good, but they are also super expensive. And again, some name dropping of tools. We have Defensix, we have the Peach, then we have the FUF, and finally Radamsa and American Fuzzy Lop. Then we have attack proxies, which this is a pretty generic term and there are different kinds, but the idea is that you create this machine in the middle attack where you put yourself between the client and the server, so you can see all the traffic that's going there, and you can inspect it and you can modify it usually. This used to be a lot easier back in the old days of when the most connections were just plain text HTTP, for example. Nowadays, we're getting a lot of HTTPS, which is great for security, but from the hacking point of view, it usually means that you need to bypass this TLS encryption. And what that means is that you basically insert your own certificates to the client, so that the client actually trusts this machine in the middle. So yeah, typical tools for this is Burp Suite, which is I think it's the kind of industry standard for web application security testing. And there's also the Open Web Application Security Program, OWASP ZAP, which is a kind of a free alternative. And if you want to try to hack websites, these are the tools for you. And then there's, for example, the machine in the middle proxy, which can also break TLS connections. But again, these are just tools, and the key is to see what's happening, see what kind of data is flowing between the client and server, and then figuring out what can we do with this data that can make things work the way we want. And moving on, like, you are developers. Anything that you are using to develop systems basically can also be used for hacking. And of course, as you're developers, you can also create your own tools. And that's also a really nice way to learn things, learn about hacking. But of course, it's good idea to, before you start writing your own tool, just do a little Google search and see what's already available for you. Then we have reverse engineering tools, which are used to transfer binaries and other low-level formats to a more readable form. So when you just get an exe or whatever binary, it would be nice to see what's inside, and these are the tools for that. Here's a screenshot of a tool called JDX GUI, and it's a tool that's used for reverse engineering Android APK files. And because these files are, like, Android apps are made in Java, so it's really nice and readable. The output format is really nice and readable. And then you can do things like, well, just search for secret, and you can find a lot of secret text here. And of course, these are not probably, but oftentimes you might end up actually seeing, okay, they had some hard-coded credentials or something like that inside the APK. Other tools in this category is Kidra and IdaPro, which are both very famous, but also kind of, I would say that there are specialist tools that they take a little while to kind of learn to get to use. And finally, we have exploit tools. And these are the tools that you use to actually break into systems. And when we think about security testing, I would say that this is often not that necessary. So often it's enough to just show that, hey, here's a vulnerability, you should fix it. But we also have tools that can be used to exploit the weaknesses or vulnerabilities and pivot further into the system and the networks. And now I'm going to show you this tool called Metasploit, because it's really fun and it has this hacker aesthetic. Now this is Metasploit. It's a command line tool. It's actually a kind of modular framework, so you can see that there are a lot of exploits and auxiliary stuff, different payloads, encoders, and whatnot, and it keeps on growing and evolving every day. So how do we use this then? Well, I'm going to exploit a vulnerability on the system that I know it's there. Strangely, it didn't actually appear on my Greenbone scan, but there you go. So I'm going to use this exploit for a IRC server. There. And when you load an exploit, you can then write show options. And basically for this exploit, you just write which host you want to attack. So we will set remote host like this. And when we compromise the system, we also want to run some code there, or we want to do something there. And in this case, I'm going to set up this reverse shell. So it's going to basically give me shell on that machine. So my payload will be this Unix type reverse shell. And for that, I will also need to tell it to that payload that, okay, this is my own address, so it can phone home. So let's see, now our options look like this. Our target port, our own IP on port, and then we say the magic word. Exploit. Yeah, and we have a shell. So let's see. Directory listing is here. We are in this kind of a folder on this kind of a machine. So yeah, that was, well, just a brief demo. So when you see this sort of things in YouTube videos or that sort of stuff, then you know that, okay, that's just a Metasploit framework they are using. Now it's time to wrap things up. I think I've already said about 1,000 times that hacking is about understanding the systems and knowing the typical mistakes. So you being developers, that's also already a great foundation for that. So hacking can be a fun and a great way to expand your current knowledge, and internet is filled with information so that you can learn more and get deeper to this. Though do take things with a grain of salt, because not all information is correct and things are also improving and progressing at a tremendous pace. So some things are out of date and there is a lot of hype also out there. I do warn you that if you start learning and if you start hacking systems, only hack systems where you have permission. So only hack systems that you own yourself or where you have a permission from the other party. Some further material that you can check out. OWASP has some great testing guides and their Juice shop, which is a vulnerable web application. There's the Watchwigger Web Security Academy and some other resources available. YouTube is full of videos and stuff. Also, your company might have this security champion program, and if you're a developer who's interested in security, then that's definitely you. And finally, you can find your local hacking or security enthusiast group and go there and meet some new people and learn some new things. And with that, it's now time for Q&A.